So today I'll be speaking about Crystal Lang, and as you can see, my talk's title is Meet Crystal, Ruby's compiled younger sibling. So this is one of my favorite quotes, and knowing that our creator is looking after every one of us gives me great confidence and belief in everything I do. And sorry, Gio, I have to show this. Um, so I work at a company called RedPanthers. We are a software development company based out of Cochin. We focus mainly on Ruby and Ruby on Rails development, but recently we have started doing a little bit of Elixir and Crystal as well. You can find us on Twitter using our handle RedPanthers HQ. And my company sponsored me to be here today, and I'm grateful for that. So I'm from the beautiful city of Alapi. It's a city in Kerala, India. It is one of the most famous tourist attractions in India. It is known as the Venice of the East because everywhere you go, you see canals around everywhere. So it is one of the beautiful places in India. So if anyone is planning to see, if anyone is planning to visit India or Kerala, do let me know. I'll show you around. So let's get started. Before that, you might have noticed I named my talk Meet Crystal, Ruby's compiled younger sibling. So this tweet, I drew inspiration from this tweet to name my talk. And Matt's, as you can see, Matt's reply was, respected younger sibling. What do you think about Crystal? And he replied that, respected younger sibling. So I drew inspiration from this tweet and I named my talk. So thanks, Matt. So, Crystal. Fast as C and slick as Ruby, that's the ideology or that's the motto of Crystal, and that's the philosophy that Crystal language is built around. It tries to be programmer friendly, productive, and it tries to give you that happiness when you code in Ruby. At the same time, it tries to be performant, type safe, and highly efficient. So let's look at a little history. Crystal Lang was born at Manastech in the early 2011. Manastech is a software consultancy firm based out of Buenos Aires, Argentina. And actually, Crystal was started out as an experiment, a group of programmers experiment to see how compiled Ruby would look like. So the version 0.1.0 was rolled out in the 19th of June 2014. As of now, Crystal is 0.2 3.0. And during that time, developers at Manas were primarily working on technologies like Java, C#, D, and Golang. So later on, they got introduced to the awesome dynamic languages like Python and Ruby. And their idea was to combine the best of both the worlds into an awesome programming language. And that's how Crystal was born, to combine the goodies of dynamic typing and the type safety and the better control of your data in a statically typed environment into a single programming language. And that's how Crystal was born. And the name Crystal, in the beginning, the name of the programming language was Joy. And since it is heavily inspired by Ruby, they wanted to name their programming language. They wanted their programming language's name to be something similar, like Ruby. And they thought of a gemstone, and they thought of a nice file extension, and .cr looked like a nice file extension, and eventually they named their programming language as Crystal. So influences. Before that, how many of you know about Crystal already? Oh, so many of you. Okay. Crystal's syntax is much like Ruby's, okay? On a plain set, you will be, it is very difficult to differentiate between those two if you just take a plain look at the code. But Ruby is not the only one language that influenced Crystal in its development and in its measurement. There are a host of programming languages that contributed or that inspired Crystal to be what it is right now. For example, Crystal's concurrency model is heavily inspired by Go's concurrency model. And the Swift language inspired the non-nullable types, whereas C# and D is the source of inspiration for the value types. The multiple dispatch pattern was copied or inspired by the Julia Lang. And the Crystal's core team look a lot into the Rust world, into the Rust ecosystem, or their design decisions and their compiler while designing Crystal. So these are some of the languages and some of the tools that heavily inspired Crystal to be what it is today. So why Crystal? Why I decided to talk about Crystal, or why my company chose Crystal for one of the microservices that we want to write for our POS application. That's what I'm going to share in this session. So first, let's take some of the major features of Crystalline. First and foremost, I think the most important part is the syntax of Ruby that gives you the productivity or the happiness, right? That is the most important thing, right, as a programmer, to be happy writing your code, to be expressive writing your code. So the Ruby-like syntax take care of the most important thing, that is your happiness, that is your productivity. And Crystal is statically typing, statically typed languages, and it uses LLVM. LLVM is a set of compiler tools, a set of reusable components that can be used to design and develop compiler front ends and back ends. And it gives a great set of optimizations that can be utilized to further speed up or enhance the programming language. And Crystal has built-in native WebSocket support that will be a game changer when it comes to building highly concurrent, highly dynamic, real-time applications. And Crystal is garbage collected. It currently uses BOMGC. It is a pretty solid garbage collector. It supports both incremental and generational garbage collection. As of now, Crystal team is sticking with BOMGC, but there are plans around the corner to switch to incremental compilation. By the time they might consider another alternative. And another cool feature of Crystal language is lightweight processes, and it is highly concurrent. If you look at the memory footprint of a Crystal program, you can see that it consumes as minimum resources as possible, and that is one of the greatest features of Crystal. And the ability to another thing that that really impressed me about Crystal was the ability to build an executable of your program and data. That executable that can be ported and it will execute just fine anywhere a typical C++ program would do. And I would like to show an example. There was a blog post by Sardar Duggyol, the author of Kimal. There is a micro framework for Crystal, and in his blog post exactly named Why Crystal, he showed an example, and I think I want to show you the same. So if you look at this code, it's just a typical nth Fibonacci number finding program that uses recursion. And let me try running this program. Let me time this. And this is a machine that has 8 GB of RAM and an SSD. And it is going to take roughly 15 to 16 seconds to execute this program. I know it is pretty argumentative, but Ruby's big number implementation is much faster. So when we are trying for a very big number, Ruby's performance will be better. Of course, I know that, but this is a simple example of the performance difference, to show the performance difference. So as you can see, it took nearly 16 seconds to execute this program. And let me execute this using Crystal. As I told you, we can reuse almost all of the code that we have already written in Ruby with Crystal, except in some cases where we have to use the type annotations, considering that Crystal is a statically typed languages. And with only minimal few minor tweaks, we can almost reuse any Ruby code that we have already written in Crystal. And you'll be able to see it just took just 1 second to execute the program. And you might have remembered me telling about LLVM compiler optimizations. So, and about building an executable of your program. So let's try that. So if I use the minus minus release flag, what it is going to do is it is going to use all the optimization, compiler optimization that LLVM compiler generation tool has to offer that further increases or further optimize your code. So if you can see right now, you can see an executable here. So let me time the execution of that executable, portable executable file. See, it just took less than a second. So that's the kind of performance that we are talking about. But I know it's an argumentative, while comparing the performance of one language with another, it's always argumentative. But it's a low-level example of the performance difference that we are talking about. And to have the ability to explicitly define the type of your program leverages, a great amount of control over the data, on the data that flows through your program. Apart from the improved performance, we can get rid of all the unnecessary manipulations that the data has to go through, given that you know the type of your data beforehand. Then, as Ruby developers, many of us often come across this, right? Undefined method, blah, 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 called on nil class. So, this is something that often annoys us. But given that Crystal is a compile time, it checks for type safety in the compile time, we can get rid of so many nil errors. This error often occurs when we call a method on something we thought would be an object, right? So Crystal, being a statically typed language, leverages you the option to get rid of so many errors that could happen, that could go to the runtime instead of in the compile time. So you won't be left out to debug many nil errors in the runtime. And this is a simple comparison between Ruby and Crystal. Of course, Crystal is statically typed, and the ability to check for nil type errors on compile time. But we all know that Ruby has awesome, and there are so many libraries out there that we can reuse, that we can easily extend. But considering that Crystal is still in the very early stages of development, Crystal is still a baby, the ecosystem and the tools and the libraries are not much out there as of now, but it is slowly taking traction, it is slowly gaining momentum. Crystal has an improved runtime performance, and it compiles to native code. And the type inference in Crystal, I would like to show you some examples of the type inference in Crystal. Crystal tries to require as few types as possible all the time. But there are certain scenarios, or there are certain instances that you have to define the type of a variable or object explicitly by yourself. Such as the class and instance variables, you always have to define the type of your class and instance variable all the time. And the Crystal's underlying algorithm is going to guess the type of your data based on it, the type of your variables or objects based on its possible uses in your program. So I'll show you that. This is one sample. This is how we do the explicit type annotation when it comes to instantiating instance variables and class variables. I think this is the most tedious way, and us Ruby developers will be using the next two most common methods more, I think. The next is assigning a literal value, and the name, the instance variable name will be referred to as of type string, and any method that is called upon the name that does not respond to string class is going to always throw you an error in the compile time itself. Same applies to the age instance variable. It will be evaluated to 32-bit integer type. Um, and assigning the result of invoking class method new is another way of instantiating our instance variables. And not all the time we'll have to do it via a custom class method instantiation, but we can always refer to a more generic data type like an array of integers, like you can see in the second example. And another possible way or another popular way of defining types in Crystal is as method argument with type restriction. Type restriction is widely used in Crystal while writing Crystal code, and this is one typical example of using type restriction. So the name variable will always evaluate to a string type, and any method or any operation that does not adhere to the type inference is going to throw you a compile time error. This is one typical example of union types in Crystal. Union type is a cool concept in Crystal. So if you can see, I have two possible uses of my variable A. As I told you earlier, Crystal's underlying algorithm is going to guess the type of your variable based on the possible uses of that particular variable in your program. So if you see the first conditional, if the condition passes, it will have a 32-bit integer type. If not, it is going to evaluate to a string type, right? So in the compile time, it is going to make a union of these two possible types. So that is the union type concept in Crystal. And in the runtime, based on the condition that evaluates to true, the type of the particular variable A will be inferred as 32-bit integer type. As Ruby developers, the one thing we all are proud of the Ruby's awesome, cool metaprogramming capabilities. And what about Crystal? Is metaprogramming possible in Crystal? Yes, it is. And metaprogramming in Crystal is possible via an abstraction named macros. So this is a simple example of how metaprogramming is done in Crystal. So I have this macro defined with define method that takes two arguments, the name of the method that is going to be defined and the return value. So when I call define method with the arguments foo and 1, it is going to name the method as foo and return the value 1. So you can see there. So macros is how we achieve metaprogramming in Crystal. Typical use cases of Crystal. Crystal is going to be widely used in microservices and REST APIs, considering that it has less memory footprint and highly performant. A lot of the microservices and REST APIs can be written in Crystal. That improves performance, that gives you a better experience. And I believe that is one area that Crystal is going to be heavily used in the coming time. And command line tools. We all know those awesome command line tools written in Ruby, right? Like CocoaPods, Vagrant, recently the Fastlane. So all these tools, imagine them written in Crystal with the improved performance and the ability to build your the ability and ease of with we can distribute it as an executable. So I think command line tools is one area that Crystal language is going to flourish, and it is going to be widely used in the coming times. Video games and if you look at GitHub, you can already see people using Crystal for video game development. Many of us must be already knowing about the SFML library for developing video games, and there is a nice wrapper for Crystal language. It is called CRSFML, and there are so many projects that are using CRSFML to build simple video games, and I've been seeing them a lot recently. Then another application of Crystal will be on building bots, chatbots, Twilio, Twitter, all these chatbots. So Crystal will be very efficient to write chatbots and all. Then compilers. Just imagine a beginner looking into the source code of a compiler. But Crystal team believes that this language, Crystal, can be used effectively to build future compilers. So that is one area that they are concentrating on. Recently, there have been a GitHub chat with the Crystal core team, and they emphasized on building compilers using Crystal. And the major advantage, I think, will be even a beginner looking into the source code of a compiler written in Crystal is going to understand more compared to any other alternative. Then data science, even though it is not matured yet, Crystal has been started using a little by little in the field of data science, even though it lacks all libraries and abstractions that Python language has. But still, people are trying Crystal in data science. And Internet of Things is another area where Crystal is going to be widely used in the coming times, because it tries to use as minimum system resources and memory resources as possible. So with a very little memory footprint and system resources, it will be able to run. So we'll be able to see Crystal embedded in small devices and will be widely used in Internet of Things. And in our case, we had this POS application, point of sales application, and we wanted an executable file to be installed at the POS machine that reads the log that the machine is generating, and it makes a third-party API call, get the result, make some expensive resource-consuming calculations on the data received, and make an API call back to another third-party resource. And this is a small service that we have written in Crystal at RedPanthers. And the client wants, it was very difficult to convince the client about using Crystal at the very beginning, because he had no idea what Crystal is about. But we insisted on trying out Crystal, and as of now, we haven't faced much difficulties going with that approach. And yeah. So what's stopping you from using Crystal? So that's the thing that needs to be discussed, and I think Crystal needs more time to mature as a programming language, as a community, as an ecosystem. So considering that, even though Crystal has been around for a while, it is still a baby. It needs more time. It needs more effort to mature as a programming language and a company and as an ecosystem. Crystal has no Windows support yet, and for the Crystal version 1.0, it is not blocking the release of 1.0. So that is, even though Windows support is in the roadmap of Crystal development, Crystal 1.0, as I told you earlier, Crystal is still a baby. It is 0.3.0, that is. When it rolls out as a full-blown programming language in a version 1.0, it will still lack the Windows support. And I think by the time 1.0 is released, the development team, the core team, will be shifting more focus for having Windows support. And parallelism is still a work in progress, and this is the one major feature that Crystal core team is focusing on. By the time Crystal will be 1.0, Crystal will have parallelism support. So that is their major aim. That is their major goal for version 1.0. Is it production ready? There are companies using Crystal in production. RedPanthers is one of them, and there are different companies using Crystal in production. But as I told you earlier, it is still in the very early stages of development. Since the time it became a full-blown programming language, or till the time it reaches 1.0, there could be breaking syntax changes. So many people are afraid to use Crystal in production yet. But if you see the GitHub page, there are quite a few number of companies that are using Crystal in production already. So is there a Rails? Amber is a framework which is heavily inspired by Rails, which is trying to be the Rails of Crystal. And one cool feature about Amber is the moment you scaffold, it comes up with a really nice default template. It's a framework that tries to be the Rails of Crystal, and very active in development. Amethyst is another option, another framework, and it also draws inspiration from Rails. Kimal, we can say that it is the Sinatra of Crystal. It is a micro framework for Crystal, and it is pretty awesome. I used it personally for a while, and I felt it a very efficient tool. It uses very little memory and system resources as possible. I know benchmarks are very opinionated, but still I would like to show you a very small benchmark of a program. So the program we are talking about is making an API call to the IMDb database, passing through an authentication layer. It implements two endpoints, the /titles, which eventually returns all the the title of the movie, the release date and all, and /names, which will be the name of the actors and the crew. The code is more or like the same. So let me show you the benchmark directly, so it will be more interesting. So this is a simple comparison. The same code written in Rails, Sinatra, and Camel. If you can see the CPU consumption, the memory usage, and the throughput. Even though it's a benchmark, I know it's opinionated, but still it's a difference that catches our eyes. And you can see the throughput difference here, the average throughput and system resource utilization. So why now? Why this is the right time to talk about Crystal, to give Crystal a shot or build an application using Crystal? As I told you earlier, Crystal is still in the very, very early stages of development, and this is the right time to influence the Crystal core team or influence the language. So our inputs or our voices will have an impact as of now, because they are free. They have the freedom to make breaking changes till the time it reaches 1.0. So as a community, I think this is the right time to influence Crystal. I hope all of you will give Crystal a shot. I hope all of you will try to contribute to the Crystal's source code. And together, let's make Crystal as awesome as possible. And to conclude, do I think Crystal is going to replace Ruby? No, never. But what I think is Crystal is going to be used more and more by Ruby programmers. Crystal is going to be used by Ruby programmers to rewrite parts of their program which they feel needs more performance, which they feel they need better control on the data flow in their program. So parts of their program or parts of their application, microservices are going to be written in Crystal. And Crystal and Ruby, I believe Crystal and Ruby are going to go hand in hand for a long distance, and I think that journey will be pretty exciting. A big thank you from all of the Ruby community from India. We are a country where over 109 languages are spoken and over 1,000 dialects and variations. So a big thank you from every one of us at India, every one of our Ruby community from India, to organizing this event, to having us here and making this awesome event. We look forward to coming here again. Thank you very much.
Thank you so much. So, as usual, questions? Wow, okay. Let's go for the nearest one first.
Hello, I'm Budi. I see Crystal just like Kotlin, the new kids on the block. Anyway, I have several questions for you. First, how many microservices in your office that are written by Crystal? And second question is, could we use some test framework like RSpec or Spec in Crystal?
Yes.
Thank you.
As of now, we have one microservice written in Crystal, only one. And there are test frameworks like RSpec. Can't really recall the name here, but there are test framework that are used extensively. So there are a number of ones, and it will be pretty much like writing an RSpec test cases. I hope that answers my question.
So we could use RSpec instead in Crystal.
Yeah, we could, but not entirely.
Okay, thank you.
Thank you so much. The next questions? Okay. Oh, yeah, okay. Move it. Ya kan?